We're continuing our conversation about exponents, and now we're going to be working with some examples where the base of the exponent isn't just an x or just a y. You can see here that the base of the first example is xy, and the base of the next example is xy squared. We're going to be doing some more examples where the base is sort of more complicated than just a single variable. So first, let's talk about how you simplify something like this. Here you have xy, x times y, all to the third. So remember that what this means is that you have xy times xy times xy. Okay, well, when you're multiplying things, the order doesn't really matter, right? I mean, 2 times 3 is the same as 3 times 2, which means that if you have x times y times x times y times x times y, really you can write this as x times x times x times y times y times y. And now we've already talked before about how to treat something like this. When you're multiplying things that have the same base, you add their exponents. So over here we have x times x times x. All those things have the same base. The base is x. And so we're going to add up their exponents. Well, you might be asking, what are their exponents? Well, if you don't see one, that means that you just have a single copy. So here's, this is saying that we have x to the 1 plus 1 plus 1, and then y to the 1 plus 1 plus 1, or x cubed times y cubed. And in general, this is always how it works. I've sort of drawn it out longhand in this first example, but you can see that if you had just started at the beginning and applied the 3 to the x's and the 3 to the y's, that would be the correct answer. And that's not a coincidence. That's in fact always how it works. So keeping that in mind, let's do a few more examples. Here we have x times y squared all being cubed, right? All being raised to the third power. Note that this is different from the next example where x times y is being squared and then all of that is being cubed. So here, without the parentheses, y is the only thing being squared. X is just a single copy of x and 2 copies of y. And here you have x and y both being squared. Okay, so keeping this in mind, what are we going to do, or what we're going to do is cube each of these pieces. Just like we did here, we had an x and a y, and we ended up cubing both pieces. So we're going to take the 3 that's on the outside, and we're going to say, okay, well, we have an x being cubed, and then we have y squared being cubed. So, of course, we just get x cubed here. That's already simplified. And then we already talked about how to deal with something like this. When you have an exponent being raised to another exponent, you multiply the two exponents together. So this will be y to the 2 times 3. So x cubed times y to the 6th will be the answer here. Okay? So you can just take this outermost exponent and apply it to everything that's on the inside. So here we have a complicated base, meaning more than just a single variable, and it's being raised to the second power. And then all of that is being raised to the third power. What we're going to do first is anytime you see an exponent being raised to another exponent, you can simplify those things together. So that's a topic that we've already talked about. So this is going to be x times y, and then instead of raising it to the 2 and then raising it again to the 3, we're just going to raise it to the 2 times 3. So this is x times y being raised to the 6th power. And now we're back to a situation that's similar to the first example, right? So we're just going to take that 6 and apply it to each piece. So we get x to the 6th times y to the 6th, and that's going to be the answer here. So now let's look at a couple more examples. The first is 3 times x being squared. So that's 3 times x all squared. Don't let the constant in the base trip you up. You want to treat this just like you've treated the other ones. So if this was an x times y being squared, we would square the x and square the y, Well, there's not going to be anything different done because there's a 3. We're going to take this 3 and it's going to be squared, and then we're going to take the x and it's going to be squared. Okay, so we can simplify 3 squared. So 3 times 3 is 9, which is going to give us 9x squared. Okay, simple enough. Now let's do this example. Again, we have a 3-term base. Now we have a -2 and a y and a z, all in the base of our exponential, and then we have an exponent of 4. So the rules still apply. It doesn't matter that the negative's in here, it doesn't matter the 2's in here, everything is just going to get this 4th. Right? Everything's going to be raised to the 4th power. There's one thing that's slightly tricky with dealing with negative numbers, is you want to keep the negative inside the power, and I'll show you what I mean here. So we want the -2 to be raised to the 4th power. So let me finish working this and I'll talk a little bit more about why the parentheses are around that too. So we have y to the 4th and z to the 4th. Okay, so what is -2 to the 4th power? Well, if you take -2 times 2, or times -2, that's 4, times -2, that's 8, times -2, that's positive 16. So the answer will be y to the 4th and z to the 4th. So the answer here is 16y to the 4th, z to the 4th. Note, so let me maybe just write this here. Note that -2 to the 4th is not positive 16. Okay? It's negative 16. Because if the negative's not inside the parentheses, then it doesn't get raised to the 4th power. So just like here, there's a difference between xy squared and xy all squared, there's a difference between -2 to the 4th and -2 all to the 4th. So watch your negatives and your parentheses when you're dealing with these problems. -2 to the 4th is not the same as -2 all to the 4th. So that's an important distinction.